Okay, not sure what week this is, but we're going to be covering chapter 10 this week. As you can see, I'm not in my normal home office. I'm at my parents' house. For those of you who've asked, thanks for your inquiries. My dad came through the procedures fine and things are doing great, so no issues there. I will be here probably the rest of the week. So you can still contact me via, you can text me, you can do whatever you normally do, and I'll still respond. But it means the video is going to be a little rougher than normal, and it means that I didn't bring my iPad with me, so I can't do the normal demonstrations. Okay, but that should change come the weekend. Okay, so a couple of things just to bring us all up to date. Some things that I mentioned in the office hours meeting last week. First off, office hours this week. I think I said it was going to be Tuesday, maybe Thursday at 7. I think I'm going to have to change that to a Wednesday, so I'll change that. I'll change that on Moodle as well. Okay. Okay. The other thing I want to talk about is that the point of this whole program that you're doing is to teach you the skills to get you to incorporate the stuff into the classroom. Okay. And the syllabus for this class mentions a final project. We haven't talked about that project yet, and it's probably time to do that. I think most of us now have the basic skills in Java programming. So you have the basic stuff. We're getting now into the more advanced object-oriented stuff, and that's what we'll continue on in that vein. But we have a good base level of stuff there. Okay. So for the project, what I want us to be thinking about is how we can teach some of these concepts in the classroom. And it's going to be different. I was under the impression that most, if not all, of the students in this program would be high school, and that's just not the case. So it's going to be up to your expertise to figure out, of the things that we've covered and the techniques that we've covered, what is going to work best for the students that you teach. Okay, so that final project then is going to be kind of like the things that you're supposed to submit for your portfolio for this class. It's going to be a lesson plan, something that a project you could teach that covers the same kinds of things we're covering in class. Okay, so if you're a high school, even if you're a junior high, it probably should be Java based, I would imagine. If you're an elementary school teacher, then it may have to be something more generically algorithm based, or talking about for loops or repetition loops, or flow charting or UML diagrams, or some other kind of activities that you think would be useful. Okay, and you certainly are free to again use your expertise and your experience to come up with something for that. Okay, I'll put an assignment out there on Moodle at some point. If you have questions or suggestions, make sure you let me know. When it comes to teaching your students, you are the content experts. Okay, I teach them only when they're 18 years old and above. Okay, so I don't teach the younger ones. Okay. The other thing I want to talk about this week is going to be the format of the final. Okay, so after some discussions with Heather and some of the students, I think that it makes more sense that there will be 3 programs again on the final. It's programs only, no multiple choice, no essay type questions. But I think I'm going to, in essence, make 3 separate 1-hour exams. Okay. So that means that if you no longer will have to carve out 3 hours of contiguous time to take the final. You'll be able to break it into 1-hour chunks. Okay. I'll try to make the programs equal in the time that they take. But it does mean that if you only take 20 minutes to get the first program done, you can't bank those hours. You have to do it the other way. I guess it's probably possible, I think about that I could make 2 options, one with the 3 hours exam and then 3 separate 1-hour exams, and you just have to take either 1 3-hour or 3 1-hour. If anyone's interested in that, let me know. It doesn't really matter to me. A little more setup on my part, but it shouldn't be a problem. But that if you would do that, if anybody wants the 3-hour, then once you start, then it would be just like before. You would have to do it all within those 3 hours. Okay. We'll talk more about the format of that, how all that goes as we get closer to exam time. Okay. So I wanted to talk about a little bit about chapter 10. Again, I don't have my iPad, so I can't do the drawings, which will limit things a little bit. But I think this is just continuing on what we've covered before, okay? So we talked about inheritance last time. And I guess before that, we talked about composition. The composition is the has-of relationship. It's where a car has an engine, for example. And in that case, you just use engine would be an instance of engine would be one of the member data of the car. So there's nothing else that you do. And then last chapter with inheritance, we talked about the extends word, keyword. Okay, so you take from the example I did, the car class will extend the vehicle class. Okay, that gives us the superclass and the subclass names that we use, the nomenclature there. Okay, so and that's an is a relationship. Okay, so a car is a vehicle. Commissioned employee is an employee. A salaried employee is an employee. Okay, so we're going to go further along with looking at those classes that have inherited subclasses. Okay, and it gets us to this concept of polymorphism. Polymorphism is one of the very key concepts of object-oriented programming. Okay, and it's the idea that let's see, does the book have a quick and dirty explanation that I can then put in my own words? Let's see. That's our overview. So it doesn't really give us a definition. Very good. That's interesting. Gives us some examples, but it doesn't really give it that. Okay. Well, so I'll just give you my definition of it. It's basically the idea that when you have a superclass subclass situation. So let's say, I think they use an example of quadrilaterals and rectangles. So a rectangle is a quadrilateral. Okay, so if you have a method that takes a quadrilateral as an input, then you could send it a rectangle and it's going to be okay. Okay, because a rectangle is a quadrilateral. And that's where the polymorphism comes in. Okay, so look at our example from employees, where you've got the employee superclass, and you've got the commissioned and the salaried, or even the university one where you have university personnel, whatever it's called, that breaks down into students and employees, and the employees breaks down into faculty and staff, and the students can break down into undergraduate, graduate, all that. They're all community members. So if you have a method that takes a community member, so you're just printing off a roster or just the names of everybody that's involved. And if you have in that community member class that you're storing first name, last name, and address, well, then you could send it an instance of either a community member or a faculty member or a student or a staff person or whatever. And because all of those instances have an is a relationship with the community member, then that function will work. Okay, so it just means that if you develop a method with a superclass in mind, that it will also take any of the subclasses. Okay, and again, if you think about how that works, which I had my diagram to draw, but whatever member data that you have in the superclass, then all of the subclass also have that member data. Okay, so that's why that works. It doesn't work the other way around. Okay, and the book gives a lot of, you could do this, yeah, don't even go there. Okay, so we're just going to say you can't do that. So if I write something, again, look at my vehicle class that I did. If I write a method that takes an instance of a car class and it uses car particular things, I can't send it a vehicle. I can't send it a boat. Okay, so it doesn't work that way. But if I have a method that takes a vehicle class, I can send it a car or I can send it a boat. And that's perfectly okay, or whatever subclasses we have. Okay, so hopefully that will make more sense. And the book does give a fair example of how it's going to do that. Okay, and then in section 10.4, it gets to this idea of abstract classes and abstract methods. Okay, the idea behind an abstract is it's something that you can't really instantiate. You can't make a new one of. And if you think again about the employee class that you did, we have the salaried employee and the hourly employees, let's say, if that's our hierarchy, okay? Then an employee can't just be an employee. They have to be either one or the other, okay? So if we make the employee class an abstract class with the abstract keyword, okay, it means you can never make an employee. You would have to make either an hourly employee or a salaried employee. Okay, so the superclass is still there. All the normal rules follow, except that you can't make an instance of an employee. Okay, and you do that when you want, another example they give is a shape class. If you have a generic shape class, it's going to hold things such as color. It may hold some kind of XY position, all those things. Okay, then you can't make a shape. You have to make a triangle or a rectangle or whatever you make. Okay, so then the book is going to talk about that in more detail, but that's the basic idea. Okay, it's a way we can use to organize things. Okay, the next section, section 10.5, goes through a case study on payroll systems using polymorphism. Okay, and it has figure 10.2 is a diagram they're going to use, and it's got an employee class that then has the subclasses of salaried employee, commissioned employee, and hourly employee. We've been working with this example before. Okay, we then have the commission employee can also be the base plus commission employee. Okay, so all of those are going to use the extends keyword in their definitions, of course, except the employee, and they're all in an is a relationship, or at least the hierarchy. So a base plus commission employee is a commission employee is an employee, the salaried employee is an employee, and the hourly employee is an employee. Okay, so what they're going to do in this instance, sorry, my light keeps going in and out as I move around. Again, not a good lighting situation. What they're going to do basically is they're going to make the employee class abstract. Again, no employee is just an employee. Okay, they're all going to be one of those things. Okay, so you make that one an abstract class. Okay, the other thing that you can do, if you make an abstract class, an abstract method in the superclass, okay, and you don't define that class because it's abstract, but you create an obligation in all of the subclasses. Okay, so they've got an earnings method. Okay, the earnings method is defined in the superclass as an abstract method. Okay, and it means that every one of those 4 subclasses or subclasses have to implement their own version of the earnings. Okay, so it goes through some examples there, and then the opposite of abstract, which we've been doing all along, is called a concrete class. Again, a concrete class is one that we can actually make an instance of. Okay, and then it goes through all of those examples, gives you all the code that you need to set that up. And again, if you're unclear on things and getting ready for the homework, it's not a bad idea to go ahead and type in all of those functions. I think that would certainly make some sense. Okay, that way you can kind of see what's happening. Okay. Okay, it gives, this chapter is mostly explaining that example, that case study. Okay, so it talks in chapter 10.7 on final methods. Okay, so a final we use instead of constant as a keyword. That basically means that it can only be changed when it's instantiated. Okay, so it gives us just again, this book gives little teasers, and then that's all we're going to talk about. So I don't think we have to worry about that too much yet. Okay, and then in 10.8, there's a deeper explanation of issues with calling methods from the constructor. Okay, they've already said that you shouldn't call overridable methods from the constructors. Okay, so they give you another example here of why you should do that. Again, it's a fairly short section. Okay, 10.9 is a little bigger issue, so we need to think a little bit more about that, and that's the idea of creating and using interfaces. I think we said before, but it may not have sunk in the rationale or what I was really saying. Other languages like C++ allow multiple inheritance, so you can have 2 parents or 5 parents or 100 parents. It doesn't matter. Okay, that's not how it works in Java, because there's often an issue if you inherit from 2 different classes and they both have the same method, which one do you preference? Okay, so there's some issues there. So Java's gotten rid of that. Java instead uses what are called interfaces. Okay, so interfaces are a way to put some common functionality to a group of otherwise not related objects. Okay. And the book gives a more in-depth explanation of that. Okay. And it also talks about the difference between an interface and an abstract class. And with an abstract class, with the, if we're using an interface, we would use the keyword implements, okay, on the interface, okay. And then it's going to go back to the example we were doing before and add a payable hierarchy, okay, so that employees are payable, invoices are payable. Otherwise, they're not connected. Okay, so we're going to create an interface for the payable part, okay, that goes in top of, okay, and it's going to, in our UML class diagram, it's going to have a dotted line for an interface, okay, and typically we'll have the word interface in angle brackets on top of it as well, okay, and it just gives us, we can make some information, some methods, and some member data that's common to anything that's payable, okay, and that's how that works. Okay, so there again, there's an example of how you would get that working. Okay, let's see, what else do we have to talk about? 1010 on the Java SE8 interface enhancements, and same thing in the next section. We don't need to worry about that too much. Okay, and then in 1012 it talks about private constructors. Constructors are usually public. Sometimes they're private. Again, that's not going to be a big deal for us. It's a fairly short section. You can read through that if you want. But yeah, we're not going to worry too much about that. 1013 is the difference between creating an interface as opposed to an implementation. And it talks about the difference between doing normal inheritance and doing the interface. Okay. And it comes down to basically if you have what we would say are tightly coupled classes, which mean they share a lot of commonalities, shapes, vehicles, things like that we've done. Then it makes sense to do the implementation or do the inheritance hierarchy, okay? But when you have other things that are not, that may share some common behaviors, but really aren't the same thing, like invoices and employees are not the same thing, then you want to consider an interface, okay? And also the book says in 1013 too, that interface inheritance is more flexible. You have more flexibility. You're not tying the subclasses with as much. Okay. So there's some more stuff about that. And then again, we're not doing the GUI stuff. We have enough to do without that. And that kind of ends up the chapter. Okay. So hopefully as you get into it, it will make some sense. Okay. And the homework for this time is going to be just a couple. 1014, which for that you're going to implement the shape hierarchy that's in figure 9.3, and then each two-dimension shape should contain method get area to calculate the area of two-dimensional shape. Each three-dimensional shape should have the methods get area and get volume. Okay, create a program that uses an array of shape references to objects of each concrete class in the hierarchy. The program should print a text description of the object to which each element refers, also in the loop that processes all the shapes in the array. Determine whether each shape is a two-dimensional shape or a three-dimensional shape. If it's two-dimensional, display the area. If it's three-dimensional shape, display its area and volume. Okay. And again, on those, you don't have to worry about asking the user for anything. You can just hard code those and that'll be fine. Okay. Then the other one I want you to work on is 1019. That's under the making a difference section. Okay. And it's the carbon footprint interface. So in this case, we're going to create an interface that's going to have some data about what the carbon footprint would be. Okay, so you're going to write an interface carbon footprint with a carbon footprint method, and then each of the classes that implement that interface so that get carbon footprint method will calculate the carbon footprint for that class. So each class that would otherwise not be related. Your car creates a carbon footprint, an airplane does, a factory does, cows in the field do. Okay, so each of those are very different, but by making this interface, then you're pushing down this idea of the get carbon footprint function that each of these classes then have to implement themselves. Okay, so that's the idea for that one. Okay, and I think that will be relatively straightforward. Okay, So that's it for this week. Sorry, the lecture was not as graphical as normal because I didn't have my iPad. But let me know as you're looking through things if you have questions, and I can always do an example or get us started on the homework with another video. I do have a clip, so I can pop up the clips without any trouble. Okay. The other thing is from the other homework, I'm behind on homework again, having to travel and all the stuff with my father has put me a little behind on that. So I think I've got some of the homework problems at home already done. I just need to make a video of them. I will probably in chapter, let's see, what's not graded? 7, is 7 graded yet? I think I just graded 6 maybe, let's see. No, I graded 7, I believe, because that was part of the last test. On 8 and 9 are due now, I guess. Okay, 10 will be due next week. I may just go through and grade those real quick, which means you're not getting some feedback, not getting the feedback you normally do. So basically, if you have them there, you're going to be okay for those. And if I do that, then I will definitely make sure that I release either the videos, a video of the solution to those problems, or the answer so you can check them. Okay, then you can always ask questions after that. Okay, we'll see how much time I get to catch up, but that's the game plan for now. Okay. Okay, so if you have any other questions, make sure you let me know. Again, the meeting time for office hours may be a little bit in flux depending on other things going on in my life, but right now, let's say it's Wednesday at 7 should be the time. Okay. Okay, so hopefully you guys have a good week and let me know if you have any questions.